Greetings and welcome back to network analysis series. We've discussed about the network data. We discussed about adjacency metrics. We also have seen a video where we were discussing about the properties of the elements, which is nothing but your nodes and edges. So there are a lot of metrics that we need to calculate. And in this video, I'm talking about the centrality metrics. Centrality is basically a fundamental tool which allows us to quantitatively measure the importance of these elements. When I say elements, the centrality measures are applicable for both nodes and edges. And centrality can also be seen as the count, because majority of these metrics are depending on the count of connections for node or the number of connections for, or basically the edges that we're talking about. So let us see the different type of metrics that are applicable for nodes as well as for edges. To start with, the node centrality measures. It basically allows us to understand how important a node is or a vertex is. And we have multiple centrality measures. Some of them are defined here. The degree centrality. It is a very simple and the first computation that we do. It talks about the number of direct connections a specific vertex has. Then we have something called as betweenness centrality. In betweenness centrality, we try to look at the number of times a specific node acts as a bridge. That means it basically tries to have the shortest paths between two other nodes, and it tries to be at the center of two different networks. And nodes with high betweenness basically control the information flow in the entire network. They can also be seen as the gatekeepers. When we talk about closeness centrality, it talks about the number of, I should say, direct connections for a specific node. You can see the closeness centrality is a little enhanced version of degree centrality, where degree centrality talks about direct connections. Closeness centrality talks about how close it is to all the other nodes in the network. Right? That means we also look into the connections which are not directly related to a node. For example, if I have node here and here, let's say A and B. So this is a direct connection, and that's what degree centrality talks about. And this is nothing but the shortest path. But I may also have another node C. So in closeness centrality, we also measure the distance of node A to node C, which basically traverses through two paths. So we collect all these connections for one node with respect to all the remaining nodes in the cluster. And then we try to measure the inverse of the total distance. If distance is large and from for one node to the rest of the nodes, and if I take inverse of that, that means the node is very far away from all the other nodes. Right? It basically talks about the distance, and larger the distance, that means it is far away from the other nodes. Lesser the distance means it is close to the other nodes in the network. These three basically talk about the connections itself. But we do also have other centrality measures like eigenvector centrality. Then we have PageRank. We also have something called as Katz centrality. These other metrics that we are looking at, they just do not look at the connections, but they also look at the quality of these connections. Right? It measures the influence of a node based on its connections to other high scoring nodes in the entire network. So these metrics help us evaluate the real world influences, especially in marketing perspective. These metrics would hold very, very good. They give us the influencer information. So on and so forth. There are other metrics that we can discuss with respect to the nodes. But moving on to edges. Edges are nothing but your connections. The most important centrality measure that we look at is the edge betweenness centrality. Here it quantifies the shortest paths, the edges, right, between node pairs traversing on a specific edge. It's similar to your node betweenness centrality only, but this is basically also allowing us to define the communities within the network, sub-communities. And there is one algorithm which we will be discussing as part of this series. This is Girvan-Newman algorithm, which helps us to detect communities in the network. And here, the Girvan-Newman algorithm uses edge betweenness centrality to effectively detect the communities. Then we also have edge load centrality. Of course, edge load centrality is not practically implemented in any networks in real world applications. It's more from a computation perspective, but it is very similar to betweenness centrality measures only. And right, it tries to identify the potential bottlenecks, especially in infrastructure structure networks. So these are some of the centrality measures that we should be familiar with. We will be discussing more in detail about the betweenness centrality in the coming videos, because that also helps us to detect communities. See you around in further videos. Thank you.